blast off.
All right.
Hey.
So we started out this unit by talking about what rational numbers are. And then we talked about decimals, and I explained terminating decimals and repeating decimals. Repeating decimals use the bar notation over the number that repeats. And so now we're going to talk about writing rational numbers as decimals. So I'm starting with the example 5/11. Yes? So I'm going to start by making my long division symbol right on the side of my fraction. And I have the corner of it touching the line for division. So now I'm going to pull my 5 down and into my long division symbol right there. So now I have 11 is my divisor and 5 is my dividend. Can I divide 11 into 5?
No.
Right? It's not a big enough number. So I'm going to put a decimal and some zeros, and I'm going to carry my decimal straight up into my answer. So now I'm going to start with how many times can 11 go into 50? It can go in 4 times. And it gives me 44. So if I do that and I subtract, I've got a 6. I'm going to bring a 0 down because I can't put 11 into 6, but I can put 11 into 60. So how many times does 11 go into 60? 5 times, that's right. And that gives me 55. With 5 left over. I'm going to extend this out, put some more zeros. So I'm going to draw a line down to here. I'm going to put that 0 in. How many times can 11 go into 50? 4. Which would give me 44. And would give me 6 left over. We'll do it one more time. I'm going to pull this 0 down and make it 60. How many times can 11 go into 60? 5. Which gives me 55. And 4 left over. Are you seeing a pattern? Yes. So this is a repeating decimal.
Does it have to put a line under 5?
Well, the way you would write the answer, so your answer is equals 0.45, and the bar goes over both the 4 and the 5 because the pattern is it keeps repeating 0.45, 45, 45 into infinity. The line goes over the numbers or the pattern that keeps repeating. And then I would box that out because that's my final answer. Yeah. Mm-hmm. So let's do another example. Here I am going to do -7 3/8. So the first thing I need to do is change that mixed number into an improper fraction. So that means I'm going to multiply the 7 times 8. What's 7 times 8? Yeah. Yes, it is. It's 56. And then I've got to add this 3, right? So it's 56 plus 3, which is going to give me 59. Because we were multiplying positive and negative numbers, it's a -59. And I'm going to put that -59 over the original 8, right? So now I can turn that fraction into division to get my decimal. So I'm going to put my long division sign right on the side, and I'm going to carry that 59 down straight into my division symbol. So how many times can 8 go into 59? 7 times is right. And 7 times 8 is 56, which gives me 3 left over. So I'm going to put a decimal here and a couple of 0 placeholders in, carry my decimal up to the top. And now I'm going to carry a 0 down because 8 can't go into 3, but it can go into 30. So how many times does 8 go into 30?
Twice.
3 times. What is 8 times 3?
24.
Yep. So 30 minus 24 gives me 6 left over. And I'm going to carry down another 0 because 8 can't go into 6, but it can go into 60. So how many times can 8 go into 60? 7 times. And what is 7 times 8?
56.
Yep, 56. Which will give me 4 left over. So I'm going to carry down this 0 because 8 can't go into 4, but 8 can go into 40. How many times does 8 go into 40? 5 times. 8 times 5 is 40, which gives me nothing left over. So remember, if there's no sign in front of a number, it's positive, right? And here we have a negative sign on the inside. So if you look at the rules on the wall for integer operations, when we multiply and divide with different signs, what kind of answer do we get? Negative. So I'm going to put my equal sign over here. My answer is negative 7.375. And I box that out.